Hi, everybody. Welcome to the Oracle Analytics Summit and welcome to my session. I'm Francesco Tisiot and I will talk to you about how to become a data scientist with Oracle Analytics Cloud. First of all, something about me. I'm the analytics tech lead of a company in the UK called Rittman Mead. You can find a lot of what I write, especially about Oracle Analytics, in our blog post, in my company website. And also you can find me on my email, on Twitter. Last thing about me is last year being appointed as Oracle ACE Director for my efforts and my evangelism in the Oracle Analytics space. Something about my company. Rittman Mead is a data and analytics company. We work on mainly three pillars. The first pillar is data engineering. So we take the data from any source, we change the shape, and we load to any target. The second is analytics. We started in this field over 10 years ago, where everything was centralized BI. Now we do still centralized BI, but we also help clients doing self-service analytics and trying to find the right balance between centralized and service. So between stuff which needs to be provided by the IT department and stuff that can be free discovery and self-service analytics. The last pillar is data science. We have a set of data scientists within our team that can help clients solving data science problem, or they can help clients teaching how to solve data science problem. So next time that they have a problem, they can fix by themselves. I believe you are here because you want to become a data scientist. But first of all, we need to understand what a data scientist is. There is kind of this mythological figure about the data scientist being someone that everybody wants, but nobody can find. So I did a little bit of research in order to define what this figure is about. A data scientist really is someone, first of all, that knows a little bit how to code. How to code in more or less two languages, which are Python and R. Python and R are the languages which are mostly used in data science. But doing data science only by coding is not the right direction, because only coding is what a software engineer does. In order to do data science, you need also to have some sort of knowledge about what's back. So most of the data science is based on linear algebra or on statistics. This is what is a data science in the books, but the reality is that a data scientist needs to work in a specific business context. So it needs to have some domain knowledge and needs to use the domain knowledge in order to solve the problem. As you can understand, it's a huge set of knowledge which is required in a unique person. This means that it's very hard to find the right person that knows everything that you can see here. Still, data science is popular. Data science is needed by a lot of companies. And if your company is not doing data science as of now, well, you're really too late, because all your competitors are already solving problems with data science. So how can we solve the problem of needing to solve data science problem and at the same time not being able to hire data scientists because they are too expensive, they are not located where your company are? In order to solve the problem, we need to basically take the low-hanging fruit theory. So instead of trying to upskill a lot of people to data science, we need to bring data science down to earth. We need basically to democratize data science, to provide a way of solving data science problems with a simple set of tools. Some examples to this. First of all, I'm a business analyst, and I want to understand what are the drivers of my sales. With the old way of doing things, the only option that I had was to ask to someone else, to ask to an expert, who was telling that based on his experience, I can guess that A, B, and C are the good drivers of your sales. The problem with this is that it's based on a personal experience. The personal experience brings the personal bias. So it could be correct, or also could be not correct. It can analyze only a subset of the data because he's located in a special location. He was in the company only in the last few years. And also because in nowadays, the amount of data that we are looking and the amount of dimensions that we have in our dataset is too huge for a single person to being able to analyze them all. What if the tool that we are using for our analytics purposes could give us some information about what are the statistically significant drivers of our sales or our dataset every time we upload, every time we connect to a dataset? This is what is called augmented analytics. It's basically the analytical tool, instead of only displaying charts, already telling us important information about our dataset. The second use case, I want to optimize the 100 calls that I'm doing on a daily basis. So I want to have an idea if a client is going to accept an offer that I'm going to make it. If I start with no knowledge, I'm basically in a 50-50 chance. 50% the client could say yes, 50% it could say no. What if with a simple tool, I could build a basic machine learning model that could give me an accuracy of 70%. So with 70% confidence, I could say that this client is going to accept my offer. I could target only the client more likely to accept, and possibly this, without any involvement of a data scientist, is already a 20% upsell for my company, done by a business analyst without any interaction with a data scientist. This is great because it allows data science problem to be solved by anybody. And if you are in the Oracle world, well, you're lucky because Oracle Analytics Cloud allows you to do that, allows you to solve those problems from a business analyst point of view. So the question now, how do I become a data scientist with OSC? What we will see in the rest of the slide deck is basically a set of standard steps that any data scientist does when solving a problem, and we will see how we can mimic them with OSC. First of all, the first thing that you need to do in order to solve a data science problem is define the problem. You have to define the problem in a way that the computer can understand. For example, if you want to maximize the number of clients that will accept the offer, you will need to find a KPI that will tell you the amount of clients accepting the offer divided by the total amount of clients that you called. If you define the problem in a mathematical way and in a way that the computer can understand, then you will be able to optimize your KPI and you will be able to apply the problem and to solve the problem with data science. So the first thing, define the problem. Once you define it, then we can start with what I call the 6th step into data science. The first step, I need to connect to the data. There is no data science without connecting to the data, without data. So no matter what, no matter where your data is stored, you need to connect to it. Second step, cleaning. Most of the times we will face data sources which are far from perfect, which contains data that we don't want. So an important step, and this is where a data scientist spends most of the time, is in order to clean the dataset, to prepare the dataset in order to create machine learning models. Third step, transform and enrich. Not only need to clean, I also need to understand my data and change a little bit the shape of my data. And we will see much more details later. 4, I need to analyze. Once I clean and transform my data, I need to check what are the columns, which could be a good predictor or not for my target column. Then it's time to create machine learning models and evaluate, create more than one and compare one to the other and choose the best one for solving my problem. The last option, the last section of this path is to actually use one or more machine learning models in order to do prediction. This is where you really start solving problems with data science. So let's see more in detail how can we do the same 6 steps that a usual data scientist does in any data science problem with Oracle Analytics Cloud. First of all, you need to connect. And OSC is perfect because it allows you to connect to a huge variety of data sources. First of all, if your data is in an external data source, no matter what, you can connect to it. If it's a MySQL DB, if it's an Oracle database, if it's a Dropbox folder full of Excel files, OSC will allow you to connect to that. The good thing about OSC is that it allows you to do that And at the same time, you can query what the IT department defines as the golden KPI within your company. So if you want to compare the overall number of customers, which is a certified number from your IT department, together with some external data sources, you have the flexibility to do that within the tool. Second step, we need to clean. What do we need to clean? Well, actually, this is a very important step. Every time we face data sources, especially when we face raw data sources, we could potentially have missing values. For example, in our client dimension, the birthday of a certain client can be missing. What do we do if we have a missing value? How do we substitute? Do we remove the row? Then we could have values which are slightly wrong. Like in this case, mark and mark, we immediately understand that is the same mark. But due to a typo, if we don't fix the value, the machine learning model will treat those two values as different. Then, for example, if we are trying to build a predictive model for the city of Milan, should we still care about the data coming from the city of Rome? If the data from the city of Rome are not relevant, we should remove them from our data model because, first of all, they will generate some pollution in the data model. Second, the machine learning model will be slower to learn if we ingest more data. After removing the irrelevant observation, it's now time to do column labeling. This is very important because the machine learning model will not care less if you feed it with a column called column A or with a column called person name. It will always produce the same result. What it changes is for you, because you will have then to explain why the model took some decision. And it's far, far easier for you to say the model took a decision based on the person name than the model took a decision based on column A. So labeling columns is important for explainability of the model. Next option, next thing to clean, outliers. This is a simple case. If, for example, we want to predict the income of any employee within a company, should we keep the salary of the CIO within our dataset? The salary of the CIO will be 5, 10, 100 times higher than any other salary. So probably it will generate noise within our dataset. So understanding the outlier and removing them is a very important step. Next thing that we need to clean is feature scaling. A lot of models are working with what is called the Euclidean distance, which is basically the distance between various points in a graph. If you have, for example, if you want to predict the house price based on the square meters of the house and the number of bathrooms, you can understand that the two features are on a really different scale. If you don't put all the features in the same scale, then the machine learning model will try to optimize far more the feature on a larger scale than the feature on a smaller scale. So it's very important to put all the features on the same scale. Then another option to clean is not really something that we have to clean, but is something that we will face when we attach to raw dataset. And is that the raw dataset most of the times will have a lot of details that we may want to condense, we may want to aggregate. Last, we may want to split our dataset into training and test, because we want to train our machine learning model and then evaluate the model performances with data that the model didn't see it before. So you can understand there is a wide range of stuff that you must understand and clean. How can you do that? OAC, again, has a tool called Data Flows, which allows you to do exactly that. It's a mini TL tool that allows you to create pipelines and allows you to join several data sets together, to do aggregation, to do filtering, to do transformation. If you think at all the problems that we saw before with an ETL idea in mind, you can start understanding that those are all transformations which are really easy with an ETL tool. But also OAC doesn't stop here. Also OAC automates part of them. For example, missing value, feature scaling, and train test split are stuff that is already automated by the tool, so you don't have to take care of it. Next step, feature engineering. Let's see some examples. For example, I have a location and I want to add the zip code to my dataset. I have two locations and I want to add the distance. Let's take the example that I want to predict the taxi fare, and I have the starting location and the end location. I may want to calculate the distance because that will be a good predictor for my taxi fare. I have the name of a person and I want to guess the gender. I have the day, the month, and the year in different columns, and I want to condense the information in a unique column containing the date. Again, if you have an ETL mindset, the two transformations on the right are easy to achieve with Dataflow, with the same mini ETL tool that we have been talking about before. However, the two transformations on the left, if you think with all the other analytics tools, what you will have to do is to come out with an additional data source that, for example, matches the location to a zip code, and then solve the problem yourself. This is not true for Oracle Analytics. With Oracle Analytics, all this is solved for you. Every time you attach to a data source, the tool itself will start suggesting enrichments. So for example, if you attach to a data source containing a country, it will suggest you enrich the columns with, for example, the capital, the population, the continent. As you can understand, is a lot of new knowledge that you can put in the system. And it works really well, especially if you are in the cases of geographical enrichment. If you want to do more, if you want to do spatial enrichment, for example, you may want to understand which customers that you have are 200 kilometers more far than any shop that you have. Again, this is really easy to do, just a little bit outside of Oracle Analytics with a tool which is called Oracle Spatial Studio, but that can be really easily integrated with Oracle Analytics Cloud. If you want to do spatial transformation, understand which clients are within a certain range, you can use a tool that can be integrated with OAC. Then we need to do some data analytics. The first thing that any data scientist does is willing to have a data overview. OAC provides you that, provides for each column, the column name, the data type, and a set of sample values, together with an indication of if the column is an attribute or a measure, and if it is a measure, which type of aggregation the tool is performing on top of this. Of course, you can change almost everything. You can change to treat a special column as a measure and to change the aggregation type. Still, this is your starting point in order to analyze the data set. However, this is the starting point, and this is the starting point also for a data scientist. The data scientist probably will understand, will have a better idea on which columns will be a good predictor for your target column. What OAC does, it solves this problem for you. You can click on any column, right-click, and click on Explain. Explain will start giving you the distribution of that column across your data set, and also across any of the dimensions that you define in your data set. This is just the first step. Any visualization that you see here can be included in a project canvas and can be shared to your colleague, to your boss, to anybody in your company. The most interesting part of Explain is the next, is what is called key drivers. Key drivers will tell you which are the statistically significant drivers of your target column. So in this case, I'm trying to predict if a wine is good or bad, and it's telling me that the columns that I should use in order to predict that are the price and the region. So it's already giving me enough information to create a predictive model. Then it's time to build the model. OAC has various options to build a model. I divide into main categories. The first one is what I call easy models. And it's really simple. I can just plot my data set. In this case is a scatter chart. And if I right-click on any point in my visualization, I can right-click and I can say add statistic, and I can choose which type of machine learning model I want to use. In this case, for example, I want to understand the clusters in my dataset. I select it, and I can immediately see the result. And I can see the result, and I can also change the algorithm that I'm using and also the amount of groups. So you can see that I can achieve already some data science options, some machine learning models. I can create some machine learning models with just 2 clicks. This is useful. However, it has just one limitation, that the model will be created based only on the columns that I'm displaying in the graph. What if I want to do something more specific? Well, first of all, what if I want to read something about my dataset? Not only visualize, but read something in detail. Well, again, OSC provides something called natural language generation. So I just need to feed the visualization language narrative with the columns that I want. And the tool will start explaining me what it can find in the dataset, what the statistical significant drivers of my dataset are. What if I want to build something more specific? What if I want to choose which algorithm and which parameters I want to use to create a machine learning model? Well, I can do that again with Dataflow. Dataflow has an option to do more machine learning model training. I need just to select which type of problem I want to solve between numeric prediction, multi-classifier, or binary classifier or clustering. Then once I select which type of problem I need to solve, I then can select which algorithm I want to use in order to solve the problem. Once I select which type of algorithm, I can select also the parameters. As you can see here, OSC gives you a lot of options in order to create machine learning models. You could start thinking, well, this is kind of hard, which I can maybe guess which type of problem I'm trying to solve, which type of model should I use, and which parameters should I use? Well, that's hard. But let me tell you something. There is no golden set of algorithms or parameters that will work all the time. What most data scientists do, they do trial and error. And you can do the same with OSC. You can select a model, select a specific algorithm, select a set of parameters, create the model, and then go back, change the algorithm, change the parameters, and create a new model. Everything will be stored for you in OSC. And the good thing about OSC is that it gives you a way of comparing various models. So for every model, classification model that you're creating, OSC will provide you this, which is the confusion matrix. Will tell you how many predicted values are matching the real values and how many not. So you can do also some math and understanding if a model is performing better than another one. You can choose the model performing better for the KPI that you defined upfront and the KPI that you are trying to optimize. Once you choose which model you want to use, you can use it. And it's, again, very easy. First of all, you need to attach to a data set that you want to use in order to create the predictions. And then you can simply select Create Scenario. You will be able to select which model you will be using in order to create the predictions. And then you will need to do some matching between the columns which are available in the data set that you are using and the columns that are available in the data set that you use to train the model with. Once you did that, all done. You can start using the prediction in any visualization that you want. All very easy. Well, congratulations, you did the same step that a data scientist does in any problem. Now, can you consider yourself a data scientist? Well, the reality is nearly. As I said, data science is a lot more complex. You will be able to solve some data science problem with OSC, but the reality is that there is a lot more than this. There is a lot more knowledge if you want to achieve better result, best result, or if you want to apply machine learning to huge data sets. Still, you solve a data science problem. And at the same time of solving a data science problem, you start understanding a lot of concepts related to data science. First of all, data cleaning. You started doing data cleaning on top of the data set, understanding why data cleaning is important. Second, feature engineering. You created new features that maybe are good predictors for your target column. Third, model creation and evaluation. You create one or more models and you compare them and you try to choose the best one for your KPI. Last one, feature selection. You use the explain and you understand the output of explain about which columns were the good predictors of your target column. And at the very end, even if you didn't create a model which is 99% accurate, you still created a model which is, for example, 70% accurate. Still, without the involvement of a data scientist, you possibly have 20% better performance in your company. The next step, when you want to put machine learning in production, when you want to attach to huge data sets, when you want to achieve 99% accuracy, well, that is the time where probably involving a data scientist is the right step. Especially when the data volumes are huge, that is the case of moving the machine learning to the data instead of moving the data to the machine learning as we are doing now. You're lucky because if you are in the Oracle world and if you are using an Oracle database, you have that for free. Oracle Machine Learning is a series of packages within the database that allows you to do machine learning directly where the data sits. And it's very powerful because it uses the power of the database. And it's very secure because the data never leaves the database. Even more, OML, Oracle Machine Learning in the database, can really work well with Oracle Analytics Cloud because models built in the database by a data scientist can easily, really easily be used by a business analyst in OAC, can be exposed as of now as by SQL. In the future, you will be able to select via the GUI any machine learning model built in the database. So you don't have any excuse now. You can start your path to become a data scientist with Oracle Analytics Cloud. If you want to do more, you can also go to the database, and then you can go back to Oracle Analytics Cloud and expose the results and share the results with all your colleagues. So what's next? As of now, we understood, and I've been talking to you about the theory of becoming a data scientist with Oracle Analytics Cloud. But you never saw a real example. Let me give you some more information. First of all, a series of blog posts that I wrote a while ago about the same set of steps with more detail on how to become a data scientist with OAC. The second reference is actually a video where you will see it live. So you will see how I solved a problem of guessing, estimating if a wine was good or not using Oracle Analytics Cloud. The third one, the third reference, is Inside Lab, which is a program run by Rittman Mead, where you can basically call our data scientist, and we will help you out solving a data science problem. And also we will teach you how to solve it. So next time you will be able to solve the data science problem by yourself. So summarizing, if you have a data science problem, don't call a data scientist. You have all the options under your hand to start becoming a data scientist yourself. Thank you for watching.